Hello all and welcome back. So in this video, let us now move forward and see how can I find the diameter of my tree in an optimized manner. Okay. So in the last video, we did a very much in-depth analysis to understand that how can we find the complexity of some operations which are overall we are doing on our trees. Okay. Now we first saw that how the height function is having the complexity of big O of n. Okay, because we are going to each and every node. So this was having a complexity of big O of n. For finding the complexity of this diameter of my tree, where I was making calls on the left and the right half, we imagined two types of trees. One which is balanced and one which is skewed. Now, once we have made this particular kind of an equation, because I can say that my nodes are getting halved in here, while here node is just getting reduced by 1. So n minus 1, n by 2. Okay, so again, just kept it up very slowly so that each and every one of you would have understood. We saw that how they are very analogous to our merge sort and bubble sort. Overall, also, we could have founded the complexity by the analysis which we have learned, but just making sure that we are able to connect them with the algorithm we already know is a lot easier, even to explain in interviews as well, right? So we saw that how this is equal to merge sort, and merge sort is having the complexity of n log n. Similarly, this is bubble sort, having the complexity of O(n) square. And to just overall help us write this better, what we did was we can say that it is O of n into h, where h is my height and n is number of nodes. Now, my height, if we will see, I can say that my height in this is log n and here it is n. Okay, everyone. So I hope this analysis as of now is clear. So now let us move forward and see how can we optimize it. Okay, great. So to optimize, let us first see this example only. 1, 2, 3, 4, 5, 6. Okay. So for this particular example, let me just draw this. I'm going to draw it a little bit small this time so we can have everything on a screen. So pay attention everyone, what exactly this tree has to do. Now what we are going to do to understand how we can optimize it. First, of course, we will have to make sure that we understand what is happening, right? Great. So we are going to just chain down each and every call which is getting made so that we are or sure that what is happening. And maybe we will just see that for the first level. So the very first thing which I'm doing in my diameter is getting the height. Okay. So great. Let's say this call is made for height. Okay. So I'm getting the height. Great. For this height, this particular node, it's going to make call to its children and it's going to give the answer once it's get back the answer. Okay. The same thing is going to happen here as well, where we are going to make this call. Okay, everyone. So just to make sure what is happening here, height, height, each and everyone is calling on its children. Once it returns, it's going to add and then return back the height. So it will get the height back. Great. So that seemed to be some work which my this particular call is going to do and the right height is going to do. Great. Now I'm calling the diameter of my tree. Okay, now I'm calling the diameter. So let's say in this particular case, we have this as diameter call. Initially, my diameter call is here. Initially, it's on the first node, right? Then I am calling diameter again on this particular node, which is 2, right, everyone? So I am saying that, hey, now you have gotten me the height. Please now get me the diameter. Great. Now let us see for 2 to get the diameter. What will it have to do? Okay, so again I have my 2 here. I have my 2 and here we have 4 and 5. Okay, so we have this 4 and 5. Now to get the diameter, what 2 will do again is it will ask that, hey, get me the height, right? So this is exactly what's going to happen. Now again, my 2 is going to be like, okay, if you want me to find the diameter, please first get me the height of my left node. So this whole diameter of tree will get called for my on my second node again, right? So root dot left is 2 in this case. Once it happens, this node, which I've drawn separately, it's going to again make a call for height. Okay, so it's going to making another call. Something which it got earlier, it's making a second call for that. Okay, so let me make this height 2. So it is saying that, hey, get me this height again. Get me this height again. And I hope you can imagine that how it's going to boil down. Okay, how exactly it is going to boil down. I made a call initially. Now I am saying that, hey, get me this height again. Get me this height again. So I made the color same, and this color coding I believe is a lot helpful. I will just repeat what exactly has happened. First we go to 1. It says that, hey, get me the height. Just see this particular call. Okay, so it makes the call to 2. 2 makes this call to 4 and 5. Right? Great. Once this is done, what happens? Then one say that, hey, get me your diameter. Okay, so 2 then goes back and gets its diameter. For getting the diameter, what 2 is doing? 2 is making another call of height for 4 and 5. This is what our code says, right? We are saying that, hey, get me this height and get me this height again. So if this would have been a very long tree, then you can imagine how many calls are we making duplicates, right? How many calls are we duplicating? Because if we will have another node here, if we will have another node here, another call, don't you think that it would have been better if 2 will have some knowledge that, hey, it is going to call again for height. Like I will have to make another call in which I will be asking for height. Right, everyone? So I hope all of you are able to understand. All I'm saying is if 2 would have some idea that it's going to get another call. So 2 calls for same information. For same information. Right? It's the same as if you have to say 2 things to me. You will not call me and say first thing, then call me again and say the second thing. Once you have connected with me, then you can say both the things, right? In a very similar way, I believe that 2 should have some idea that, hey, it's asking for height. Okay, but I will also be needing the height for my use case when I will be finding the diameter. If 2 would have this knowledge, then I think this would have been a lot good, right? 2 will have a knowledge that, hey, it's going to call me. First call is going to mate for height. Okay. Second call is going to mate for diameter. Due to which 2 will have to make calls to its node for height. I believe it would have been a lot great if 2 would have an idea and it can return height and diameter all together. Because for finding this height, for finding the diameter, okay, 2 need to have the height of its children and it is already getting that when it is returning. So what I want to say effectively, for when this call is made to 2, okay, it will get the height of its children. Okay. Using that height, 2 can actually calculate its diameter, right? 2 can directly calculate its diameter. And instead of you making a call again like this, what if in a same call, I say that, hey, give me the height as well as the diameter. Okay. So I will just draw this again so that everything is clear. Let me just make it a little bit clear. What's going to happen effectively? So if I make my tree like this, and I hope all of you are able to imagine that what benefit it's going to do, right? From the real world examples. If this is my tree, the same tree which we have drawn, along with height, okay, along with asking for height, let me get back both height and the diameter. Okay, so all I'm saying is this time, okay, let us draw and use this particular color. This time when I'm making the call, okay, get me back height and diameter both. Great. In this particular scenario, what is 2 going to do? 2 is going to make a call to this. It is going to give back the height. But using this height only, 2 will calculate the diameter as well. So it doesn't need to return, doesn't need to call it again and again. So we have actually, in a way, reduced so many calls for a very complex big tree. Okay, so I will just write this down as well. Instead of just the height, we will ask child or children to get both height and diameter. Right, everyone? So, and we have seen this how in recursion it was very helpful. If you all would have remember, I asked you all to implement that if we are returning head and tail both, okay, then how the overall linked list, the take input function of linked list can be optimized. So the same approach we are doing here. Instead of just asking for height, I am just asking for both the things. Once I have these both things, then I can easily do my work. Okay, so let us write this down, everyone. Now let us try to write the code down for this. What effectively I'm saying is def diameter of tree optimized. Okay, I will be getting a root. If my root is none, then again height is 0, diameter is also 0. Okay, so I should write it here as well, height and diameter. This is how I'm returning it. Okay, great. Now, once this is clear, once this is clear, let us move forward. Now I'm going to say left height and left diameter is root dot left. Okay. Similarly, right height, right diameter equals root dot right. Okay. So we have just got all the 4 things, but this time I have made a single call. So this function, this overall diameter of a tree is going to each and every node once. So I'm doing some k work on each node. We are going to go and see that as well. Now let us see what's going to be our answer. Okay, great. First, let us try to find what exactly is the diameter through root. So this is our option 1, everyone, which is equals to left height plus right height. Okay. So this is also here. Yeah. 1 minute. Okay, I forget the comma. My bad. Yeah. So this is going to be my diameter through root. Okay, which I can say is option 1. Option 1. Next is my left diameter, which is my option 2. And last is right diameter, which is my option 3. Now I have 3 options for this particular diameter, and I know that my final, or let me say answer diameter, is going to be max of diameter through root, left diameter, and right diameter. Okay, so maybe we can remove this, or maybe we can just commit them. Yeah. Great. So once this is clear, everyone, I should also find one more thing. It's going to be, I have to now return the height of my current tree. So we have to find that as well. Current tree height. What is it? We have seen this already. It is going to be 1 plus max of left height plus right height. Okay, so I know it's going to be a little bit complex in the first go, but don't worry, I'm going to explain it a lot better again so that you have no doubts whatsoever. And it's going to now work fabulously well. Let us get the answer in this. So let's say height diameter is diameter of my tree optimized root 1. Okay, so I can just now print height and diameter. Great. So let me use DIA or something. Why is it showing this? Should be fine. Let me use. Acha, I think height is already used. So let me use. Uh, we can use the tree height. Okay, we can use the tree height. The reason is everyone, we have this function height. Okay, so that's why it is showing different color. Great. So I have this tree height and I have the diameter. Tree diameter. Okay. Just to avoid any confusion, we have these two overall values which we can print. Great. So before I run this, let us quickly work it down how exactly it's going to be. Let us make our tree. So it is 1, 2, 4, 5, 3, 6. Let me add for this. We have to add 6 here. Okay. We have to add 4 here. I can delete this node. And here we have to add 5. Great, everyone. So I think this is the exact tree which we are seeing here. Let us make it 2 as well just. Yeah. So this is the exact tree which we are talking. So 1, 2, 3, 4, 5, 6. 4, 5, and 6. Okay. So we are able to see the proper exact tree. Should be fine. Now let's see how exactly the calls are going to get made on this particular canvas. Right. So let me use red color as it will be visible. See. First, for this one, it's going to call on 2. This time it will say that, hey, get me the height and the diameter. Now 2, what it's going to say, okay, let me just divide this because on the right side we will see the previous implementation. So new implementation, old implementation. 2 this time will go to 4 and it will say that, hey, return me the height and diameter. Great. 4, no children are there. So it's going to be 0, 0 and 0, 0. So the height which 4 will return will be 1 and the diameter is also going to be 1. Right, everyone? Because how we calculate diameter? The way we calculate our diameter is something like max of diameter through root, okay, which we have calculated as left height plus right height, left diameter and right diameter. Okay. So in this case, everyone, height is going to get returned as 1, but the diameter should be 0. Okay. Diameter will be 0. The reason being, 1 second, yeah. Diameter will be 0. Because see, left diameter 0, right diameter 0, left height plus right height 0 plus 0. So we will be returning the diameter as 0. Great. Now this will go back. Okay. And now what's going to happen? It will get similarly from here as well. We will get 1 and 0. Great. Now once it has got 1, 0, which is coming from 4, and for 5 it has got 1 and 0. Okay. Now what it has to do? It has to first make sure that it is able to find its height. Its height is going to be 2. It is going to be 1 plus max of both of these, right? So this is something which we have seen already. This is what we have written, not removing everything, but see, current tree height, 1 plus max of left height and right height. So left height is 1, right height is 1. For diameter, what we will be doing? For diameter, it will be left height plus right height. So it's 2. Okay. We have 3 options here. left diameter and right diameter. Left diameter is 0, right diameter is 0. So I will just do left height plus right height. And I will get 2 comma 2 here. In a similar way, I will get 2 comma 2 from the right side. And finally, I will be able to say that, hey, my tree height is something which is 4. Okay, great. Let us just try to visualize the old one as well. Okay, so the old one, what was happening? I was making the call for height. Okay, it was making further call for height. Great. Once this was done, I was getting it back and I was returning it back. So I returned the height back as 2. Okay. Then I used to make another call. Let me make it in blue, which used to be for second. Yeah. Which used to be for diameter. Now this node for diameter, it used to make another call for height here. Okay. Because to get the diameter in the old approach, we were again making this call to get the height. Now, if in case I have multiple such nodes, then you can imagine that how many calls I will be making, right everyone? So let's say if I have multiple such nodes, just like let's say we are adding another one of our node here, then these calls are going to be a lot high at each and every step. At each and every step, we will be making 3 calls on this particular for height. Similarly, for this one, if there is a node, 4 calls. Okay. But in this particular case, the one on the left side for the new one, each and every node we are just making a single call. The whole difference is that we are just asking everything we want in a single call and not making multiple calls. Okay, everyone. So I hope this is properly clear now. Now let us see why there is a difference in this overall case. When we talk about this kind of a tree, on left, this is a lot balanced, right? So here we are able to do and divide our operations. The nodes are balanced altogether. In this, the nodes are not balanced. They are skewed at one end. Okay, so that's the reason that it took a lot of time for this particular case. Generally, if we have to do some operation in a tree, then we are able to do it in O of n. The reason is that for a single node, the same can be done, right? So we try that if there is some information which we want for a child, then let us call once and get all the information, and let us not collect the calls to be made for different recursion, or let's say normally to make multiple calls. Okay, everyone. So I hope you get the idea that how just by using this overall way of asking for 2 things at once, we were able to get a O of n complexity finally. Okay, so big O of n final complexity. Final complexity. Right, everyone? So this is the final complexity overall. The reason is that now each and every of my node, I am just calling this particular function, diameter of my node, diameter of my node. Each and every node will be getting called with this function just once. So I can be sure that every node is doing some k work to get its diameter and its height. And if I do that k work for n nodes, then it is going to be big O of n. Okay, everyone. So I hope this overall approach, which we started with by first writing this level of code, which was a not very optimized code, how we were able to make it optimized. Again, just try to understand it once again. Try to write the code for this yourself. And just try to make this diagram, the one which I have made here in this whole page, to understand that what exactly would have happened. Okay, everyone. So I hope this is clear. Now we will be using this overall approach a lot in many questions of trees. So please make sure that you understand this properly. See the video again if it is required, because initially this might be a little bit heavy to digest, but I'm pretty sure with the intuition, the diagrams, everything which we have used, this will become a lot easy. Rather, most of you would have understood the same because of multiple runs which we have done. Okay. So cool then, everyone. Thank you. Let's meet in the next video where we will be doing more such awesome operations on our trees.